Okay, so moving on to the next section of Chapter 1 in Dive into Systems for systems programming. We're going to look at functions. The basic idea of functions is probably already fairly familiar to, just any background in computer science or programming. Let's look at an example. We've been using functions, right? We've had the main function this whole time, but we'll look at functions basically other than the main function. So, for instance, we can design a function like this, which computes the max of two integers. The sort of syntax of any function is that you initially write, the first thing you write is the return type, right? What kind of a value is it going to return? In this case, it's an integer, the integer max of these two input integers. You give it the name, you can call the name almost anything you want. And then inside the parens, you give the arguments to the function. You have to declare their type and then give them a so-called parameter name. Give it a type and a so-called parameter name. They're comma separated. And then a curly brace, which is closed at the end. So, okay, and then let's just quickly look at how this particular function works. So we declare a new variable, bigger. It will have type integer, and initially it absorbs the value of x. Then we check to see whether or not y is bigger than x. If it is, then we change bigger over to y, so that effectively, if x was bigger, then it just then the value of the variable bigger stays the value of x, making it bigger. If y was the bigger of the two integers, then the value of bigger becomes y, so that whichever one it is, right? Whichever one was bigger, the variable bigger absorbs that value, and then we it's going to print a line and then return the value of bigger. So there is our function definition, right? So I guess we call this the function declaration, and this whole thing the function definition. Sometimes functions are not meant to meaningfully return any value. So in that case, we still have to specify a return type, but we specify the return type as void. This is typically the case when you're printing and when you're saving data to the hard disk, when maybe doing some kind of communication with other programs or whatever. But there are lots of cases where you would have a function that isn't meant to return anything, but rather it is merely meant to do something like printing or saving or something like that. Okay. This prints a table, I guess, two input integers for start and stop, do a for loop, basically executing as many, with I, ranging from start to stop inclusive, and printing, I guess, the square of I along the way, tab separated. Okay, sure. So that's function definition. Now let's look about how, like when you define a function, then you want to be able to use it or call the function. So this is how you do that, right? You give the function name and then you give some list of arguments. Let's just see a concrete example. I guess let's look here. This is a function call. So you use the name of the function, which we've already seen the definition of max up above. So now we're going to call max. We give it a value. This value was determined up here. It was declared up here. But we're furnishing the argument, the first argument here, the second argument here. This is a function call. It should basically compute the max of these two values, and therefore the value that is stored in result should be 10, the max. Okay, having said all that, let's notice or observe what it's talking about here, that function calls are evaluated pass by value. So that kind of there's kind of two main ways of doing arguments in any programming language. There's pass by value and pass by reference. So let's see an example of where pass by value really sort of changes the behavior of the program so that you can kind of appreciate what it means to pass by value. Here, we don't try to change the values of the inputs. So this, right, like you wouldn't even notice the difference in this example between pass by value and pass by reference. Here, again, we don't try to change the value of the inputs, right, x and y. We don't try to assign any new value to x and y. So you wouldn't even notice the difference between pass by value and pass by reference in those examples. But I think down here, they're going to show you an example where you would notice, right? And it's because of a line like this, where we actually try to, in this case, change the value of x. So with that in mind, let's think about what it means for C to be passed by value. Now, it is now becoming so important that it is just unavoidable for us to talk about the memory address of values of variables. So what you have to keep in mind is that whenever this function is called, right now we're only looking at the function definition, but of course we have to keep in mind that the point of defining the function is to call it somewhere else. And so we're going to be in some kind of a context later on, right? Presumably in the main function. We're going to be in a context where we call the max function on some values. And here, I guess, the idea is that the values are going to be supplied by the user, right? That like whoever runs the program is going to get prompted to enter some values, and then they're going to enter those values. And then this step of the program, right, this part of the program is going to take those given values and compute their max. So anyway, the point is, at this point in the program, these values exist, and they are bound to the variables a and b, right? When we come up here, those values are getting passed in, right? The value of x is getting handed over to the variable, the value of a is getting handed over to the variable x. The value of b is getting handed over to the variable y. And let's think about this somewhat seriously, right? That there's going to be like some piece of your physical hard drive, right? What I'm going to draw here is something like your physical computer, and it has memory address, right? Like little pieces of memory, right? So this is your memory, and there's going to be an address. Now, just to keep things simple, let's just use really simple addresses. Let's say that for whatever reason, the variable a is actually pointing to, right, like its address. And by the way, addresses in memory, an address is just a number, right? A number that indicates a physical location on the physical memory device. And so let's say that A is located at address 12, just to make up a totally random but smallish number. That's certainly an unrealistic memory address, but we're keeping things simple. And let's say that variable b, for whatever reason, is located at 17. So these are, right, and that is in, the context of this, we're talking about the variables a and b, and we're supposing that the variable a, what it really, in some sense, is a pointer to this memory address 12 and 17. Now, let's just imagine, for the sake of having something concrete, that the value, the numeric value that the user entered, right, is, let's say, 2, and let's say that b is 0, for instance, right? So the address is 12, but the value stored at the address is 2 for the variable a. For the variable b, the address is 17. The value at the address, right, the value that the user passed in to get bound to this variable, that value is 0 in my completely made up random arbitrary example. when we make the the call to the function, those, like this call here to the function has to sort of remember what the function is and come up here and look at the function instructions and pass these values in for the function's instructions. And so kind of the question is, what is actually getting passed in? Is it the address of the variable? Are we passing in the 12 and the 17 so that you can look up the value? Or is it the value itself, right? And if it's the value itself, what that kind of has to mean is actually that we're talking about a copy of the value, right? Because if you pass this into the function, for the value 2 to get bound to x, would you literally extract the value 2 and move that over to the variable x? That doesn't make a whole lot of sense. I mean, basically just the answer is no, that's not what happens. Rather, what happens is that the value 2 gets copied over to the address of x. So if we wrote x over here, and let's just imagine that it has address 102, making random things up, right? Again, this is a completely fictional thing just for demonstration purposes, but it's going to copy over the value of 2. So, one thing that means, for instance, is that the value 2 is going to live at both addresses at the same time when the function is called, right? It's going to live at the address 12, which is the address of variable a, but it's also going to live at the address 102, which is the address of variable x when the function is called. And likewise, let's say that this, for whatever reason, is 57, and that we copy over the value 0. So when you make this function call, what you're actually giving the function is not the address of the variable. You're giving the value of the variable, which really means that you're copying over the value of the variable. Now, what does this? What is the importance of this? How does this sort of affect the behavior of the program? Well, especially here, you're going to see a difference between what would happen if you passed the address versus what actually happens because in C you pass the value. Here, we are assigning the value of y to x. So are we in a case where y is greater than x? I guess we are not. So this piece of code would not actually run in this example. Tell you what, let's, just so that we have an example where we actually see the stuff happen that we want to see happen, let's change these values. Let's make this 0, 2, 0, 2. And now, because y, which, y is going to get the value of 2 because it's copying over the value of b, therefore, this if block is going to execute because y is 2, x is 0. And then this block of code is going to execute, which is to say that x is going to take on the value of y. So after that step has executed, the value of x, right, the address is unchanged. That's still 102, but its value becomes 2, right? This is what happens after this line of code executes. But, and then we return the value of bigger, which I guess, this is just kind of a dummy example. So the changing the value of x here is actually not important for the logic of the program, right? It's kind of just a toy example. You would never actually do this, right? It doesn't have a good reason for doing that, except to just make this demonstration. So anyway, now let's come over and look at the main, right? Let's say, okay, we're calling main, we declare integers a, b, and res. We say that res is that. And notice that we're going to give it the values a, b, and res. And basically what I want to get at is the question of what, at this moment, at the moment of this print, what is the value of a? we just executed the max function. And the max function took in the variables a and b, bound them up to x and y, right? Or copied over the values of x and y, reassigned the value of x. The question is, when x was reassigned here, did that simultaneously cause the value of a, which is basically supposed to be bound in some sense to the value of x? Did a also get changed? That's the question. So basically right here in the main function, where we call the max function, the question is, does the value of a get changed because a is bound to x and x got reassigned? What is this going to print? That's the question. And the answer is that the value of a did not change, right? And it's precisely because c is passed by value rather than passed by reference. That is why the value of a did not change, even though the value of x was reassigned. Let's think about what would happen differently if c, or like if you had some language that was passed by reference rather than passed by value. What would happen now is you'd again start off with a. Let's say that it has memory address 12, value 0. B has memory address 17, value 2. Now what you pass in for x and y in a pass by reference language would be the memory address of a, so that effectively the variable x would just also be located at address 12, right? X would have the same address, right? When you're passing a in for x up here, what you're, in a pass by reference language, what that does is merely make x and a both have the same physical address in memory. And then when this line executes in the pass by reference version, what happens is that x takes the value of y, but really that means in this situation that so does a, because basically x and a are the same, right? They're at the same address in memory. So now the address is 12. After running this line of code, the value of x, which is the same as the value of a, becomes 2. And so now when this line executes and we come here to print at this line, and in particular we're wondering what it's going to print for the value of a, in the pass by reference example, it's going to print 2 because this edit, this assignment to x also basically was an assignment to a, and that changed the value of a. So the sort of like summary of everything that we've been talking about here is that here the print of a, I'm going to use little tick marks like that to indicate that it's the variable a rather than the word or letter. So here the print of a prints 0. And here printing a prints 2. So this is hopefully a clear enough concrete demonstration of what is different between pass by reference and pass by value. So again, this is pass by value, and this is pass by reference. Okay, so anyway, that was a long and rambling explanation, but that can be sometimes subtle and confusing, and so I wanted to try to explain it as best as I could. I hope that was good enough. Okay, so in C, things are passed by value, which means that it copies the value and not the address. Okay, the execution stack. So I think the reason why we want to talk about the execution stack at this moment is to think about how, you could have your int, so you have your main function, right? Well, let's just say that it has whatever it has in it. But the main function can and is basically supposed to call on other functions, like maybe the int max function. So maybe the max function is called upon by the main function. But then there might be some other function, like, I don't know, let's say a print function. Who knows, right? Whatever arguments it has, let's not worry too much about those kinds of details. But, and so the max function may, for whatever reason, who knows, call on this print function. And the point of thinking about all of this is that, every time a function is called, you are, in a sense, entering a new sort of context in which these computations are taking place. So in particular, what's kind of important about that is that, let's say that the main function has a variable x in it, but the max function also, one of its declared variables is the variable x, while the main function is running, right? Whatever is going on in the main function before it calls on the max function. It's got this variable x, and whatever value it has, that's, what the program is going to use. But the question is, when the main function calls on the max function and the max function is executing, what does x refer to at that moment? Because, as far as max is concerned, it's in a sort of context where there is this other variable x that was already declared and in use when the main function, was declared. And now all of a sudden, the max function also needs to make reference to this variable x. So in a sense, kind of the question is, which one wins? When the max function goes around making use of the variable x, which variable does it actually get access to when it calls something x? Well, the only reasonable choice is that it should use its own variable, right? Whoever designed the max function only got to think about the variable x defined in the parameters of the max function. So anyway, long story short, inside the context of the max function, it's always going to refer to its own variable x, even if there is some other variable in a broader context that is also called x. And so this kind of brings us to the whole concept of the execution stack, which is basically the part of the computer that is keeping track of what is the current context. Which variables are bound to which values. There's got to be some part of the computer that is both aware of the existence of the variable x for main, but also aware of the variable x for max, and is also aware of which one it should be referring to at any given moment, right? So that has to be tracked by the computer, and that is tracked by the execution stack. And so let's see. What you can think of, here's a somewhat nice diagram for understanding the execution stack. Main is the first function that is executed. And when main is executed, it, declares a variable A, declares a variable B. These variables maybe get assigned values, let's say 13 and 100. That would be done by the user. And then at a certain moment, right, these values have been assigned, but the value of res has not yet been computed. But then main makes a call to max, right? Recall how, all of that went up here. Let's erase all this to kind of clean up the picture. But the point is that main is the first thing that gets called when you run your program. We declare the variables a, b, res. At this point, the user specifies the values of A and B. And at this point, right before this line of code executes, the value of A and B have been determined, and we're going to imagine that they're 13 and 100. But the value of res has not yet been determined because we need to go ahead and make this call to max so that we can determine the return value. And so in max, right, like at the moment when the computer processes the call to max, it creates a new stack frame, right? A new stack frame, right? So this whole thing is the stack. And when main calls on max, it adds this new stack frame to the top of the stack. And whatever is at the top of the stack, this is kind of the important point. This is the sort of upshot of talking about all of this stuff, is that whatever is at the top of the stack is what determines the values of the variables. So because max at this moment is at the top of the stack, then if it looks up x, it's going to look up x in the top of the stack. And so I guess, okay, so what else, what other points do we need to make here? Two function shows examples of calling main function. This program, we declare function prototype max print. First echoes the top-down design. Okay, this is going to show one somewhat interesting thing, which is, when you're designing a program, maybe that you're going to need a max function, but you don't want to define it right away because, mostly, it's going to get defined, and how it gets defined is not the most interesting thing. So just as a matter of readability, you would like to skip defining max because you're more interested in getting to defining the main function. So, but how do you do it, right? Because if main, as it is here, let's see, where do we, yeah, here's the max, right? Main is going to call on max. What that means is that max has to go above main so that it exists at the moment when main calls on it. But what if you don't want to define it right away because you kind of want to just skip that part? It's like a boring part of the program, and you'd like to, skip down and start talking about main. But because main calls on max, you have to declare max before main. Well, this is a way you can do it, right? You can simply declare it, right? You can write, the function declaration, right? The return type, the name, the inputs. You can write all of that first and then just choose not to define it just yet, right? So you can declare it without defining it. And that allows you to now use it in this later main function. You just have to define it later on, right? So just later on, down here, it actually gets defined, but still you have the ability to use it before you define it. So that's kind of a nice feature, especially when you're trying to sort of write your programs in a way that is nicely readable, and you don't want to clutter up the code up here because it's not the most interesting part of the program, and you really just want the person who might be reading the code to get right as down to the interesting stuff as quickly as possible. So that's the point of something like that. Likewise here, right, this is, and when you do this, it's called a prototype. So you simply declare the function without defining it. And so that's a function prototype. So what else do we want to talk about here? I'm not sure that there's anything else in this specific area that really needs much conversation. So yeah, okay. Well, and that's the end. Okay. Feels somewhat like that just kind of, was just getting going talking about the stack, and then felt like there was probably more that could have been said, and then it just came to an end. But whatever. I guess we'll just move right on.